Today, plastics have become an everyday part of our lives. Due to their relatively low cost, ease of manufacture, and versatility, they are used in an enormous and expanding range of products, from paper clips to spaceships. But this same wonder material is responsible for environmental problems of epic proportions all over the world. In the United States alone, 85% of waste plastics, a colossal 25 million tons, was disposed to landfills in 2009. That's enough plastic waste to line 13 rows of garbage trucks end to end from San Francisco all the way to New York every year. Currently, the dominant method for recycling plastics involves converting them to pellets for reuse. However, such recycling is limited to plastic waste stream that has the same or compatible resins, since a significant proportion of post-consumer and post-industrial plastic waste is an inseparable mix of different polymers, such as HDPE, LDPE, polypropylene, and polystyrene, and is contaminated with dirt. It cannot be recycled and is disposed to landfills. Vantana, a waste-to-energy company, has developed technology for converting waste plastics to petroleum fuels, offering thereby the twin advantage of landfill diversion and creation of high economic value fuels, which have a host of applications. Plastics are essentially long-chain hydrocarbons, synthesized from crude oil derivatives such as ethylene and propylene. They are manufactured by linking together several thousands of monomer molecules under heat and pressure in a process called polymerization. In Vantana's technology, these long chains are cracked and molecularly rearranged to yield shorter length chains, which are then condensed to generate petroleum fuels. The company has successfully commissioned a fully continuous pilot where end-of-life waste plastics from municipal and industrial sources are converted into lighter petroleum fuels. Vantana's technology accepts raw, unwashed, mixed waste plastic from municipal, industrial, commercial, or agricultural sources. Using simple methods, it separates plastics from the incoming stream, which have high hydrocarbon content, for further processing and conversion to fuels. The technology deploys companies' patent-pending, fully continuous process to generate about 4.7 to 6 barrels of liquid fuel from 1 ton of waste plastic. The conversion process also generates an LPG-like off-gas, which can be looped back to meet a significant part of the process's energy requirements, as opposed to other technologies, which convert waste plastics to liquid slurries and waxes, using a batch mode refluxing or thermal degradation process. Vantana's technology uses a robust, fully continuous process to generate lighter fuels which approximate petroleum distillates such as gasoline, kerosene, and diesel.
What we have here is a fully continuous plant. The process is capable of removing residual solid matter such as carbon char and other contaminants that come with the plastic feedstocks such as mud and dirt on a continuous ongoing basis without the need to stop plant operations.
The technology achieves up to 90 to 95% conversion of waste plastics into petroleum fuels and LPG-like gases and generates minimal residue. It deploys standard scrubbers at process vents to ensure compliance to stringent emission norms. Using innovations in green chemistry and by designing a fully continuous process, Vantana has significantly reduced the capital cost of plant and machinery. Besides creating green jobs, the technology promotes ecological sustainability by providing a supplementary route for fuel generation, which avoids greenhouse gas emissions associated with drilling, piping, and refining crude oil. Vantana's technology offers a disruptive solution to solve the global challenge of plastic waste recycling. And in doing so, it holds the promise for a greener, more sustainable future.